This is the start of 5.2. We're going to prove some of our trig identities. We are not going to introduce any new identities. We're just proving some of the ones that we've already used. And so we'll move straight into this. There we go. So we'll look at number 6. We're going to do number 6 and 7 because these identities on your paper are divided into two sections. So 1 through 6 should be about the same, and then 7 through 12 should all be about the same. So I'm just going to do number 6 and number 7. So that's one of each type. Now, this is going to be a little confusing because we have an equal sign, but this is not an equation. Okay, it's not an equation because they're asking me to verify. So we're saying more, instead of saying this equals this, we're saying, does it equal that? So it's a question, not really a statement. So with an equal sign and an equation, I'm allowed to add to both sides. But with verifying an identity, not allowed to do that. Okay, so we are not allowed to do something to both sides of this. We can use our identities to change things though, okay? So let's look at this and think, okay, what can we change? Well, as I look up here, I think, all right, this right here, can I cancel those two out? Well, yes and no. There's a plus sign right here. So I can't just cancel it out the way I did. But what I am allowed to do is change this to be 1 over cosine squared x plus cosine squared x over cosine squared x, divided into two different fractions. Because they have a common denominator, I could add them back and get the same thing. And then when I do that, now I can say, well, those cancel each other out and I'm left with 1. Also, right here, 1 over cosine is the same thing as secant squared x. Well, notice what's on the left side. We have secant squared x plus 1, secant squared x plus 1. We got them to be the same, and that's the whole goal. The whole goal is to use our identities and make the left side be the same as the right side. I can make changes to just one side like I did. I can make changes to just the left side, or I can make changes to both, as long as I don't try to like do something to both sides as far as adding, subtracting both sides of my equation. All I can do is just use my identities. Once I get here, I'm going to sign my proof to show that I'm finished. Okay, so some common signatures are, you could use a box. Sometimes you'll see a triangle. Sometimes you'll see them use just 3 dots. But it's yours. Make it whatever you want it to be. I've had people put a smiley face. Yeah, whatever you want. So come up with some kind of symbol that's going to be your signature. I'm pretty boring. I usually use something pretty basic. But you can come up with your own little symbol that you use as your signature at the end of a proof. All right, number 7. Okay. For number 7, I have fractions, and I see that right there. That looks familiar. On my Pythagorean identities, I see that that is the same thing as secant squared theta. So I'm going to rewrite this side and say sine squared x over secant squared x plus 1. Oh, except I don't need the plus 1. There we go. Equals. And also, this would be easier if I didn't have fraction. So So I'm going to take that and move it to the top by using its reciprocal. Well, the reciprocal of cosecant is sine. So I can move it to the top and say this is cosine squared x, and then times sine squared x. Okay? And then off to the side, I'm going to write, well, what I just did. So I used tangent squared x plus 1 equals secant squared x. I used that identity. And then I also used the identity that 1 over cosecant squared x equals sine squared x. Okay? This is just to tell whoever's reading your proof, usually me, that you knew what you were doing. You did and. You have basically the reasoning for what you just did. Well, let's see here. I have a fraction on the left. I really don't want to deal with the fraction, so let's move it to the top. If I move secant to the top, it becomes cosine. So that gives me cosine squared x sine squared x equals cosine squared x sine squared x. And then voila, they're both the same. So I'll put a little signature down here. I'll switch up a little bit. And then off to the side, I'm going to say, well, what did I do? I did 1 over secant squared x equals cosine squared x. That's the identity that I used. And that's it. That's one of each type. So go ahead and try the rest of those.